Welcome back to God Maths. Mathematical literacy begins here. I hope you enjoyed our previous lesson on matrices. Today we will look at the determinant and inverse of 2 by 2 matrix. Don't forget to subscribe to this channel for more lessons. We will start with the determinant of a 2 by 2 matrix. A 2 by 2 matrix is of this form. It is a square matrix where there are two diagonals. The first diagonal is called the leading or the major diagonal, and then the other diagonal is called the minor diagonal. The determinant of a 2 by 2 matrix of this form. So given a 2 by 2 matrix, A is equal to A, B, C, D. Then the determinant, which is written as, or that A, is given by determinant of A is equal to the product of the leading diagonal minus the product of the minor diagonal. And so, for example, given a matrix P is equal to 1, 2, 4, negative 3, then we will say that the determinant of P, which is written as that P, is equal to product of the leading diagonal 1 times negative 3 minus product of the minor diagonal 2 times 4. And this will be negative 3 minus 8, which will give us negative 11. This is the determinant of the 2 by 2 matrix P. We can also have another matrix, a 2 by 2 matrix. Q is equal to 0, 1, 3, 0. And the determinant of this matrix Q will be equal to the product of the leading diagonal 0 times 0 minus the product of the minor diagonal 3 times 1. This will give us negative 3. We will take further examples on the determinant of 2 by 2 matrices. This is our first example. Given the matrices P and Q, which are both 2 by 2 matrices, we are finding determinant of P, determinant of Q, and determinant of P plus Q. And this will be the solution. We have P is equal to negative 3, 0, 2, negative 1. Then determinants of P will be the product of the leading diagonal minus the product of the minor diagonal. This will give us 3 minus 0, and that is equal to 3. Then the determinant of Q, we are given Q 4, 1, 4, 1. So determinant of Q will be equal to product of the leading diagonal minus product of the minor diagonal, 16 minus 1, and that will give us 15. In the third question, we are supposed to find the determinant of the matrix P plus Q. So we need to get matrix P plus Q, which is P plus Q is equal to negative 3, 2, 0, negative 1, plus Q is 4, 1, 1, 4. And that is equal to, we add, and this will give us 1, 0 plus 1 is 1, 2 plus 1 is 3, negative 1 plus 4 is also 3. So that will give us the P plus Q. Then the determinant for P plus Q will be the product of the leading diagonal 1 times 3 minus the product of the minor diagonal 3 minus 3, and that is equal to 0. So we will take our next example on this. Looking at the first question here, we are given the determinant of a matrix. These two bars represent determinants. and we are asked to find the value of x. So first, we need to find the determinant of this matrix and equate it to 3. And we know the determinant of a matrix is given by the product of the leading diagonal minus the product of the minor diagonal. So that will give us 7 times x, that is the product of the leading diagonal, minus negative 5 times 4, that is the product of the minor diagonal, which is equal to 3. This will give us 7x plus 20 is equal to 3. So 7x is equal to 3 minus 20. Then we can divide both sides by 7. And then our x is equal to negative 17 over 7. Then with the second one, question 2, we are given that a is equal to 10, 2x and negative 3. And we are given the value for determinant of a. So our that a is equal to product of the leading diagonal, 10, negative 3, minus that of the minor diagonal, 2 times x. This will be negative 30 minus 2x. And that is equal to what we are given here. So negative 30 minus 2x is equal to negative 32, which represents the determinant. Negative 2x will be equal to negative 32 plus 30. Then we will have negative 2x to be equal to negative 2. We divide by the coefficient of x, and we have x is equal to 1. Next, we will look at the inverse of a 2 by 2 matrix. The inverse of a 2 by 2 matrix, which is of this form, written as A inverse, this is the inverse of A, is given by 1 over the determinant of A times the adjoint of A, where adjoint of A is equal to find the adjoint of A, we negate the values of B and C to have negative B, negative C. Then we interchange the values of A and D. So D will now be in the position of A, and then A will also be in the position of D. So this is the formula for the inverse of a 2 by 2 matrix. And so taking an example, if we have the matrix P is equal to 5, negative 2, 3, 1, and we want to find the inverse of P, then we need to find the determinant of P, which is equal to and that will give us 5 plus 6 to be 11. Then the adjoint of P is equal to, we negate the values of B and C. So negating this will give us negative 3. Negating this will give us negative 2, which will give us positive 2. Then we interchange the values of D and A. So this is our adjoint of P. Then now P inverse is equal to 1 over determinant of P times the adjoint of P, which will give us 1 over 11. 11 is the determinant of P times the adjoint of P. It's also given here. So we will finally have P inverse to be equal to, we have done scalar multiplication. This times 1 will give us 1 over 11. This will give us 2 over 11. This times that, negative 3 over 11. And then 5 over 11. In scalar multiplication, the scalar multiplies each element of the matrix. We will take another example on the inverse of a 2 by 2 matrix. Given the matrices A, B, and C, we are going to find the following inverses. So the solution, we know that the inverse of a matrix is given by 1 over determinant of that matrix times the adjoint of the matrix. Now for the matrix B, our determinant is going to be the leading diagonal is 5 times 2 minus the minor diagonal is 4 times 3. This will give us 10 minus 12. That will give us negative 2. Then our adjoint of matrix B will be equal to, we interchange the values of the major diagonal and then negate the values of the minor diagonal. And so our determinant of our inverse of B is going to be 1 over, the determinant is negative 2, and then the adjoint is 2, like 4, like 3, and then 5. Then we do our scalar multiplication. This times 2 will give negative 1, this times this will give us 2, half times that will give us 3 over 2, half times this will give negative 5 over 2. This is the inverse of the matrix B. Now let's go to the next one, which is the inverse of the matrix A. And that is also equal to 1 over the determinant of A times the adjoint of A. Then our determinant of A is equal to product of the leading diagonal minus product of the minor diagonal. This will be equal to 0. That is neg 4 plus 4, so 0. Then note that if the determinant of a matrix is 0, then the matrix has no inverse. If the determinant of a matrix is 0, then the matrix has no inverse. This is because 1 over 0 is undefined, so the matrix will have no inverse. Let's move to the third one, which is the inverse of B plus A. So we will first find the matrix B plus A, which is 5, 4, 3, 2, plus A is 2, 2, neg 2, neg 2. And that will be equal to, when we add corresponding elements, we have 7, 1, 6, and then 0. So the determinant of this matrix B plus A will be equal to the leading diagonal minus that of the minor diagonal, which will give us negative 6. And then the adjoint of B plus A will also be equal to, we interchange the element of the leading diagonal and then negate the elements of the minor diagonal, so that B plus A inverse is equal to 1 over negative 6. Negative 6 is the determinant times the adjoint. And that will give us, this times that will give us 0. This times that will give us 1 over 6. This will give us 1. And then this will be negative 7 over 6. Now try the IV and the V on your own. If you have any difficulty, you are always free to contact us via the WhatsApp numbers in the description. In our next lesson, we will look at likely examination questions under matrices. See you in our next lesson.